Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is lesson 15 from module 2, and it is the Pythagorean theorem. So before we get into that, I wanted to bring this up. This is not in your module. This is the behind the scenes thing. And it says the Pythagorean theorem is a famous theorem that is used throughout much of high school mathematics. For that reason, students see several proofs of the theorem throughout the year and have plenty of practice using it. The first thing to know about the Pythagorean theorem is what it states. And the Pythagorean theorem says, if the lengths of the legs of a right triangle are A and B, so the two sides that form the right angle, these two, are called legs. This is leg B, and this is leg A. And the length of the hypotenuse is C. Hypotenuse is just the term that they use for the side that is opposite the 90-degree angle, and it's not one of the legs that forms that 90-degree angle. The hypotenuse is the side opposite the right angle. Okay, so the Pythagorean theorem states that leg A, leg B, and hypotenuse C, then the leg A squared plus B squared's leg equals the C squared, or the hypotenuse squared. So down below we have a right triangle ABC, with C, capital C, being the angle measure, vertex of the right angle. Then sides AC and BC, BC's right here, are called the legs of the triangle ABC, and side AB is called the hypotenuse of triangle ABC. Now, before I go any further here, I just want to point out to you that we use capital letters to name vertices. So capital A is this angle here, capital B is this angle here, and capital C is the right angle of this triangle. When I talk about sides that are opposite, this side here makes this angle, this side here makes angle C. When they are not opposite, they are adjacent. So this is adjacent, and this is adjacent. So therefore, the side that does not create that angle is opposite. This is the opposite. And if it's opposite to the right angle, that is called the hypotenuse. Now, another way to name these is the side is the same name as the angle that it's opposite, but we use a lowercase letter. So the side opposite capital C is lowercase c. The side opposite B is lowercase b. And the side opposite A, angle A, is the side over here. Now, when I was talking about adjacent, okay, adjacent is the side that makes the angle. So the adjacent side to angle B would be this side here, but not this one. Now this would be the adjacent with respect to angle B. These are the two adjacents, and the opposite is this B right here. So these adjacents and opposites can get confusing. Okay, so let me just get rid of this. Actually, let me erase everything now and start over. Recap. Okay, angle A. Opposite angle A is side A, which is the other two letters in the name of the triangle. So notice the triangle is called triangle A, B, C. Well, if I want to know what the opposite of angle A, the side, I should say the side opposite of angle A, then I just look at the name of my triangle and eliminate that A, because that's the side opposite of angle A. We ignore the A, and the other two is the side that is opposite, and that's BC. And we can do the same thing if we have triangle A, B, C, the side opposite angle B. Well, now I cross out my B and I have side AC, so the side opposite B, the side opposite B is side AC. And then finally, if I have triangle A, B, C, side opposite angle C, Well, I come over to the name of the triangle, cross it out, and that tells me the side that's opposite C. And sure enough, when I check my image here, my diagram, if I go straight across from angle C, then it's side AB. Okay, so that's opposites. So it's really important that you understand what is opposite and what is adjacent when we're talking about right triangles. Okay, so we got that all out of the way. The Pythagorean theorem is right here. A squared plus b squared equals c squared. So what they're saying is the side opposite angle A, which is side A or BC, and the side opposite angle B, which is side B or side AC, if I take the length of this side and square it and add it to the length of this side and square it, then I get the hypotenuse's length squared. And this is true every single time if you have a right triangle. So now we're going to just do some practice with that. Okay, so this is what you see in your module. This is lesson 15, informal proof of the Pythagorean theorem. Example 1 says, now that we know what a Pythagorean theorem is, let's practice using it to find the length of a hypotenuse of a right triangle. Determine the length of the hypotenuse of the right triangle. So here we know this leg, AC, which is opposite angle B, and we know side CB or BC, and that is opposite angle A. Okay, that's a cross, and this is a cross. Okay, so those are the sides opposite. The right angle is here at C, and the side opposite that is right here, and this is the hypotenuse. The most important thing that you need to know is how to set up the equation. The biggest mistake is not putting the hypotenuse on the right side of the equation by itself. Okay, so here's the example. In this triangle, the Pythagorean theorem states that for the right triangle, a squared, here's A, actually that's B, so already they're not lining this up correctly. The side A is opposite angle A, so A is not 6, A is 8. So I'm going to cross this out, and I'm going to say A squared plus B squared equals C squared. The side opposite A is not 6, it's 8 squared. The side opposite B is 6 squared equals C squared. So please cross this out, copy this. They are going to confuse you with opposite right from the start if you look at this. Now I'm going to square this. 8 squared is 64. 6 squared is 36 equals C squared. 64 plus 36 is 100. Okay, and since we know that 100 is 10 squared, we can say the hypotenuse C is 10. Well, that just means that we are going to take the square root of both sides, and I'm going to introduce that now. If I have something squared, the inverse is square root. If I add, the inverse is subtract. If I multiply, the inverse is division. Now we're squaring, and to get rid of squaring, we take square roots. That's the inverse operation of squaring. So if I take the square root of C squared, think of that as the square root of C times C. Well, if you think of that with a number, the square root of 9 times 9, which is the square root of 81, and I wrote 18, the square root of 81 equals the square root of 9 times 9, which equals the square root of 9 times the square root of 9. I can split those up, and the square root of 9 is 3, and the square root of 9 is 3, and 3 times 3 is 9. So when I take a square root, it's just taking, if it's a pair of items, it's just taking one of them. So if C squared is C times C, that is 2 C's, so the square root of C squared is one of those C's, if that makes sense to you. Okay. So again, please cross this out. I do not want you confusing opposites at this moment, right from the start. Okay? All right, example 2. Determine the length of the hypotenuse of the right triangle. So I'm going to write the formula. So I say this, and I say it, and I say it. Write the formula, step 1. Oops. I'm thinking about what I'm saying and not writing what I'm thinking. A squared plus B squared equals C squared. Step 1, write the formula. Step 2, substitute in the givens. A is opposite A, 7. B is opposite angle B, 3. C is opposite the right angle C. So that's, we don't know it, so we're just going to leave that C squared. 7 squared is 49. Plus 3 squared is 9. Still equal to C squared. So my rule is write the formula, substitute in the givens, simplify, and solve. 49 plus 9 is 58 equals C squared. Okay, so now, like I showed you before, they explained up here that since we know 100 is 10 times 10 squared, or 10 times 10, then the hypotenuse is 10. But now they're telling us 58. Well, I can't think of a number times itself that equals 58 because there isn't one that's not a decimal or fraction. So when that happens, I would have to take the square root of C squared, take the square root of 58. The C squared and the C, remember, just becomes C. And you're going to learn that that just cancels every time. The squared and the square root cancel, and you're left with what's under the radical, which is called a radicand. Okay, square root of 58. I want to simplify that. So the square root of 58, actually I don't want it in radical symbol. I would need to do a factor tree. So if I take 58 and divide it by 2, because it's even, 2 goes into 5 2 times with a remainder of 1, and 2 goes into 18 9 times. 29 is prime, so there's no further I can go than this. I do not have a pair of anything, so I can't simplify that. So my answer is, in this case, the square root of 58. It did not say to round to any decimals. Leave it in radical form. So the length of C is the square root of 58. Now, if you're trying to figure out what that means, well, I know that the square root of 58 is in between two numbers that could be perfect squares. And 7 times 7 is 49. So 49, well, let me just show it as the square root of 49. And 8 times 8 is 64. Now look at this. Is 58 greater than 49? And is 58 less than 64? And the answer is yes. So the square root of 49 is 7, and the square root of 64 is 8. So the square root of 58 is 7 point something. Just to give you an idea of how long that is. It's a little bit more than this, and it better be, or you did it wrong. The hypotenuse is the longest side of a right triangle. Okay? If your answer comes out to be greater than one of your legs, you made an error. Okay, exercise 1 through 5. Now it's your turn. See how you do. Pause the video. Come back when you're done, and we'll check our answers. Okay, so here we go. Always, always, always start with the formula. A squared plus B squared equals C squared. Opposite of A, 4. Opposite of B, 3. Equals C squared, which I don't know. That's C squared. That is opposite the right angle. Okay. Now I'm going to simplify. 4 squared is 16. Plus 3 squared, which is 9. Equals C squared. And solve. 16 plus 9 is 25. Equals C squared. Take the square root of both sides. That leaves me with C. The square root of 25 is 5. Now, the square root of 25 can also be negative 5, but we are talking about distance, length of an object, and we never consider negative lengths or distances. So we are only talking about the positive square root, and that is called a principal square root. That's the only thing we're going to care about because of distance always being positive. Okay, so there we go. Number 2, a squared plus b squared equals c squared. A squared is opposite a, that is 11 squared, plus opposite of b is 8 squared, equals c squared. 11 squared is 121. 8 squared is 64, equals c squared. Combine like terms. 4 plus 1 is 5. 6 plus 2 is 8. And then the 1 equals c squared. Take the square root of both sides, and c equals. Now, I always try to find out if I can find a perfect square within and simplify the radical. And I'm going to divide this by 5 because anything that ends in 5 is divisible by 5. 5 goes into 18 3 times, that's 15 with a remainder of 3, and 5 goes into 35 7 times. 5 and 37 are both prime. I am done. I cannot go any further. I cannot simplify this radical, so I'm just going to leave it square root of 185. Okay, number 3. Write the formula. A squared plus b squared equals c squared. Substitute in the givens. The opposite of a is 9 squared, plus the opposite of b is 4 squared, equals opposite of c, c squared. Simplify. 9 squared is 81, plus 4 squared, which is 16, equals c squared. 6 plus 1 is 7. 8 plus 1 is 9, equals c squared. 97 is prime, so I'm just going to take the square root of both sides and get c equals the square root of 97 because I cannot simplify that, just like I could not simplify 185. Okay, so hopefully you got those 3 answers. And moving along, there's 2 more. Number 4. A squared plus b squared equals c squared. Opposite of a is 5. 5 squared. Plus opposite of b is 2 squared. Equals opposite of c, which is c, my unknown, c squared. 5 squared is 25. Plus 2 squared, which is 4, equals c squared. 25 plus 4 is 29. 29 is prime, so I take the square root of both sides, and c equals the square root of 29. Okay, last one, number 5. Start with your formula. Write the formula. A squared plus b squared equals c squared. Substitute in the givens. A squared is opposite of a, that is 9 squared, plus b opposite of b, 1 squared, equals c squared. Simplify. 81 plus 1 squared is 1, equals c squared. Okay. Actually, let me stick with the color coding. Plus, oops. Okay, let's choose green. Plus 1 squared, which is 1, equals c squared. 81 plus 1 is 82. That equals c squared. And that's even, so I'm going to give it a shot. 82, factor tree, divisible by 2. 2 goes into 8 4 times. 2 goes into 2 once. I know 41 is prime. No pairs. Cannot be reduced. So I'm going to take the square root of both sides, and c equals the square root of 82, which is just a little bit more than 81, which is just a little bit more than 9. So this is 9 point something, so it's longer than my longest leg. Square root of 29 is a little more than 5, because the square root of 25 is 5. So 29 is a little bit bigger, so it's a little more than 5, and that is longer than my longest side. And we always should check that. I'm going to go back and do that for all of them. Square root of 97 is just a little less than the square root of 100, which is 10, so it's just less than 10, but it's more than 9, and 9 was my longest side. Okay, my longest side here is 11. 11 squared is 121. 185 is more than that, so I'm okay there. My longest side here was 16. I got an answer of 25. That's more. So 5 is more than 3 and 4. Okay? Always make sure you set it up properly and that your hypotenuse is ending up the longest side. Okay. So that is the end of lesson 15. Review this summary and go do your problem set.